Now, let's talk about laws of exponents for division. So, for you to solve division of polynomials, you have to know the basic rules or simply the laws of exponents, okay? So, our essential question is, why is it important to understand the laws of exponents? Okay, laws means it is really important. In what way? For us to solve problems, specifically division or multiplication, as well as the other operations. So let us observe the following. So as you can see, 3 to the 6th power divided by 3 squared is equal to 3 to the 4th power. A to the 5th power divided by a cubed is equal to a squared. Okay, so x to the 7th power divided by x to the 4th power is equal to x cubed. Now, what have you noticed on these expressions? The expressions above applies the first law of exponent for division. So it says that a to the m power divided by a to the n power if m is greater than n, okay? Or if the exponent of the numerator is greater than the exponent of the denominator, which is n, you have to subtract them, okay? So our base is a whole number, then subtract the exponent, okay? M minus n. Again, okay, knowing that the base or the bases of the given, the numerator and the denominator, are the same, you have to take a look at their exponents. If the exponent of the numerator is greater than the exponent of the denominator, therefore, copy the base or the same base, that is a, then subtract their exponents. So, m minus n. Therefore, our answer is a to the m minus n power. So, simplify the following. X to the 4th power divided by x cubed. As you can see, we have the same base. We have x. Then, our exponent, 4 is greater than 3. Therefore, 4 minus 3. Then simplify, x raised to 4 minus 3 is x raised to 1. In that case, we don't need to write 1. So, the answer is x. Okay, that is understandable that the exponent is 1. How about 4 raised to 8 divided by 4 raised to 6? Okay, so we have the same base, that is 4. Then the exponent of the numerator is greater than the exponent of the denominator. So 8 minus 6. Therefore, we have 4 raised to 8 minus 6 power. And the answer is 4 squared. And when we compute that, 4 squared is the same as 4 times 4, which is 16. Okay? That is the first law. Okay? Same base wherein the exponent of the numerator is greater than the exponent of the denominator. Therefore, the answer is whole number wherein you have to subtract the exponents. Okay? So let's observe these expressions. 4 squared divided by 4 to the 7th power. That is equal to 1 over 4 to the 5th power. X cubed divided by x to the 5th power is equal to 1 over x squared. A divided by a to the 4th power is equal to 1 over a cubed. Now, what have you noticed? In that case, we use the second law of exponent for division, which states that knowing that the expression has the same base, what are you going to do is to subtract the exponents. But you have to take note that m is less than n, okay? So on our second law, if the exponent of the numerator is less than the exponent of the denominator, therefore your answer should be in this form: 1 over a raised to n minus m. What have you noticed? As you can see, our answer for the second law is in fraction form. Okay? Wherein the numerator is 1. So in this case, we have 1 over, copy the base. Then, what are you going to do to their exponents? Copy n minus m, since n is greater than m. Now, let us simplify the following. Y raised to the 6th power divided by y to the 8th power. As you can see, the exponent of the denominator is greater than the exponent of the numerator. In that case, okay, so our answer is on this format, in fraction form, wherein the numerator is 1, then the denominator is, copy the base, then raise to the higher exponent, which is 8, minus the lower exponent, which is 6. So simplify, y raised to the 8 minus 6 power, that is y squared. So our answer is 1 over y squared. Okay? Okay, let's try this. 3 to the 7th power divided by 3 to the 10th power. So, on this format, we have 1 over 3, our base, raised to the higher exponent, 10, minus the lower exponent, 7. So, 10 minus 7 is 3. Therefore, this is 3 cubed. Okay, that's why we have 1 over 3 cubed. And when we simplify that, 3 cubed is the same as 3 times 3 times 3, that is 27. Our answer is 1 over 27. Now, let's observe the following expressions. 5 cubed divided by 5 cubed, that is equal to 1. X to the 4th divided by x to the 4th, that is equal to 1. A to the 10th power divided by a to the 10th power, that is equal to 1. What have you noticed? The expressions have the same bases, and they also have the same exponents. In that case, your answer should be equal to 1. Okay? Let's see. The third law of exponent for division. So, having this format, a raised to m divided by a raised to n, if m is equal to n or their exponents are the same, as I said, your answer should be equal to 1. Okay? Automatic. Like for example, let's simplify the following. X cubed divided by x cubed. So, same base and same exponents. Therefore, the answer is equal to 1. 12 raised to the 9th power divided by 12 raised to the 9th power. So, same exponents we have equal to 1. Okay? That's it. Now, let's make a connection. Given x to the 5th power divided by x to the 9th power, so applying the first law of exponents for quotient, we have the exponent of the numerator minus the exponent of the denominator, which is x raised to the 5th minus 9th power, that is x raised to the negative 4th power. Okay, because 5 minus 9 is negative 4. On the other hand, applying the second law of exponents for quotient, so we can see that the exponent of the denominator is greater than the exponent of the numerator. In that case, when we apply the second law, The answer should be in fraction form. Okay? So let's see. Fraction form, 1 over, copy the base, x, then subtract higher exponent minus lower exponent. In that case, our answer is 1 over x to the fourth power. Now, what is their connections? Okay, what do you think is the connection of these two results? Okay, so x raised to the negative fourth power and 1 over x to the fourth power. What do you think is the symbol between them, between the two results? That's right. The two results are equal. You have to take note that x raised to the negative fourth power, wherein we apply the first law, is equal to 1 over x to the fourth power, wherein we applied the second law of exponents. Okay? But here, the exponent of the numerator is less than the exponent of the denominator. The proper law to be applied is the second law. Okay? Therefore, the proper answer should be 1 over x to the fourth power. In that case, if you see an expression with negative exponent, like negative 4, x raised to the negative fourth power, you have to convert it to positive. So as you can see, we have negative 4 here, and I converted it, or if we convert it to positive, we will be having this expression. Okay, 1 over x to the fourth power. How is that possible? Let's have the definition of a negative exponent. So if your exponent is negative, like this, a raised to the negative n, what are you going to do is convert it to positive by getting the reciprocal of the base. As you can see, the reciprocal of a is 1 over a, right? 1 over a. Since a is a whole number, automatic its denominator is equal to 1. So when we reciprocal it, we will interchange the numerator and the denominator. Therefore, we have 1 over a. Then copy the exponent with positive sign. Okay, like this. Again, a over 1 has a reciprocal of 1 over a. Then copy the exponent with positive sign. So 1 over a raised to n. Like on our results, we have x raised to the negative fourth power. Okay, so the reciprocal of x is 1 over x. Okay, 1 over x. Then we copied the exponent with positive sign. So 1 over x to the fourth power. Okay? So let's make another connection. As you can see, we have x to the fifth power divided by x to the fifth power. In this case, as I said, if you apply the third law, automatic your answer should be equal to 1. So applying third law, we have equal to 1. That's it. But if we apply the first law, wherein you have to subtract the exponent, like this, so x to the fifth power divided by x to the fifth power, get the base and subtract the exponents. So x raised to the fifth power minus to the fifth power. So when we subtract them, the answer is 0. Now, what is the connection of the results? What is the connection of x raised to 0 and 1? What do you think? Very good. They are also equal. Okay? It means that x raised to 0 is equal to 1. So let's have the definition of 0 exponent. You have to take note that if the exponent of the base is a 0, automatic that is equal to 1. Again, if you see a 0 exponent, automatic that is equal to 1. For example, 2 raised to 0. Okay, 2 raised to 0, the exponent is 0. Automatic, the answer is equal to 1. If you input to your calculator any number with 0 as exponent, the answer is equal to 1. So 2020 raised to 0, that is equal to 1. Or 2020 raised to 0, that is equal to 1. Okay, any number, any variable raised to 0, that is automatic equals to 1. Raising a quotient to a power, it means that the operation on the expression is division. Like for example, x to the 9th power divided by 12 squared. As you can see, there is an exponent outside the parentheses. What are you going to do? Raising a quotient to a power. In that case, you have to distribute the exponent, or you have to multiply the exponent outside the parentheses to the exponent inside the parentheses, to the numerator and to the denominator. So let's start with the numerator. As you can see, we have x to the 9th power. What are you going to do is to multiply this squared, or the exponent outside the parentheses, to 9. So 2 times 9 is 18. Therefore, the answer is x raised to the 18th power. Okay? Now, if we do that on the numerator, we also have to do that on the denominator. So what is the exponent of 12? There is no visible exponent, therefore that is automatic 1. So the exponent of 12 is 1, so 1 times 2 is 2. Therefore, the exponent now of 12 is 2. So if we simplify this, the answer is x raised to the 18th power divided by 144, because 12 squared is 12 times 12, that is 144. Okay? Again, raising a quotient to a power, you have to distribute or multiply the exponent outside the parentheses to the exponent or exponents inside the parentheses. Number 2, 3y squared divided by 7 cubed. In this case, let's apply the quotient to a power. Take a look at the numerator, 3y squared. So let's start with 3. What is the exponent of 3? The exponent of 3 is 1, because there is no visible exponent, that is automatic 1. So 1 times 3 is 3. Now the exponent of 3 is 3. So what is the exponent of y? That is squared, or 2. So 3 times 2 is 6. Now the exponent of y is 6. That's why we have 3 cubed times y to the 6th power. Now, on the denominator, we have 7. What is the exponent of 7? That is 1. So 3 times 1 is 3. Therefore, the exponent of 7 is 3, or 7 cubed. Now, let us simplify. 3 cubed is equal to 27, then times y to the 6th power, divided by 7 cubed, that is 343. Okay, 7 times 7 times 7 is 343. Therefore, our answer is 27 y to the 6th power divided by 343. Okay, so it means that if the operation of the given expression is division and there is an exponent outside the parentheses, what are you going to do is to distribute the exponent on the numerator and on the denominator. That's why we have a raised to n divided by b raised to n. Okay, let's try the following. So I'll give you time to answer this on a piece of paper. Then later on, I will reveal the answer. I will dictate the correct answer. For number 1, the correct answer is c to the 4th power. For number 2 is 1 over 16. 1 over 16. For number 3, that is equal to 1. For number 4, the answer is 1 over 27. For number 5, that is equal to 1. For number 6, that is equal to 1 over 64. For number 7, the correct answer is 8 over x squared. 8 over x squared because negative 2 is the exponent of x. Therefore, we have to put x to the denominator, okay, to obtain the positive exponent, which is squared. That's why our answer for number 7 is 8 over x squared. That is in fraction form. And for number 8, we have x to the 6th power times y squared times z to the 8th power divided by 25. Okay, division of polynomial by monomials. So let's have this example. For us to easily solve this, you have to arrange them properly, wherein the first term should be the term with the highest exponent. Okay? So in this case, on our numerator, 8x to the 5th power has the highest exponent. Then followed by 6x cubed. After that is negative 20x. Okay? So let's arrange them. We have 8x to the 5th plus 6x cubed minus 20x, then divided by 2x. Since we can divide all the terms on the given denominator and we can divide the variable, let's divide them one by one. So let's start with 8x to the 5th power divided by 2x, followed by positive or plus 6x cubed divided by 2x, then minus 20x divided by 2x. Okay? Then let's simplify. 8 divide 2 is 4. Then subtract the exponent of x. 5 minus 1 is 4. So we will be having 4x to the 4th power. Okay? 8 divide 2 is 4. Then copy the variable x. Then subtract 5 minus 1 is 4. Next, we have 6 divide 2 is 3. Copy the variable x. 3 minus 1 is 2. That's why we have 3x squared. So, minus 20 divide 2 is 10. Okay? Then, what is the exponent of x? 1. What is the exponent of x? 1. In that case, they have the same exponent. Therefore, that is equal to 1. Okay? 10 times 1 is 10. That's why here we have 10 only. Okay? For this division, our answer is 4 times x to the 4th power plus 3 times x squared minus 10. Kindly try the following. Write your answer on your notebook. Just do the same process as I did so that you will be able to get the correct answer. Okay? Good day, everyone. Today, we will talk about division of polynomials. So for our objective, we have use long division to divide polynomials. Okay, so we will use long division. Polynomial long division is a method for dividing a polynomial by another polynomials of a lower degree. It is very similar to dividing numbers. So let us take a look at the following illustration. As you can see, we have here arithmetic long division. So here we are dividing the numbers. As you can see, we have 277 divided by 12. It says that it is very similar, or dividing polynomials using long division is very similar to dividing numbers. So take a look at this. We have here the dividend. So dividend, then divisor, divisor. Therefore, here, we are dividing 2x squared plus 7x plus 7 by x plus 2. Okay? Then, here we have the quotient 23, and here the same, we have 2x plus 3, the quotient. Okay, then we have here the process, and we have remainder, same as the arithmetic long division. Okay, so how are we going to divide polynomials using long division? So example, divide using long division. Negative y squared plus 2y cubed plus 25 divided by y minus 3. Okay, so here is how. Step 1, write the dividend in standard form, including the terms with coefficient of 0. Okay, so you have to take note that your dividend should be arranged in descending order. Okay, so when we arrange polynomials in descending order, the term with the highest exponent should be the first term, then followed by the term wherein the exponent is lower than the first one. Okay, so we have here 3 as exponent, therefore it should be followed by the term wherein the exponent should be 2. Okay, then as you can see on our given, we don't have term wherein the exponent is 1. That's why, to make it possible, you have to put 0 as the coefficient of the variable, wherein here our variable on our given is of the variable y. In that case, we will put 0y as our third term to represent the term wherein the exponent is 1. Again, here the term or the exponent of this term is 3, the exponent of this term is 2, the exponent of this term is 1. Therefore, the last term should be the constant. Okay? There is no exponent. That is how you write the dividend in standard form, including terms with coefficient of 0. Okay? You have to add the missing term wherein its coefficient is 0, if any. So step number 2, you have to write division in the same way you would when dividing numbers. Okay? We have to write this on our step 2 the way we divide numbers. Okay, so here is how. We have the dividend 2y cubed minus y squared plus 0y plus 25 divided by y minus 3, our divisor. Okay, so after that, we have the step number 3. Let's divide. How are we going to divide? First, take a look at the first term of the dividend. As you can see, the first term of the dividend is 2y cubed. So what are you going to do is to eliminate this term. How are you going to eliminate this term? You have to divide this 2y cubed by the first term of the divisor. Okay? Then after that, the answer should be written on the quotient part. Okay, here. Last time we've discussed about dividing monomials. So here, 2y cubed divided by y. First, let's divide the numerical coefficient. 2 divide 1 is 2. Then y cubed divided by y, that is y squared, because we subtracted their exponents. 3 minus 1 is 2. Okay? That's why the exponent now on our quotient is 2. So our first term on our quotient should be 2y squared. In that case, after finding the first term, you have to multiply this 2y squared to the divisor. So 2y squared times y and 2y squared times negative 3, the answer should be 2y cubed, because 2y squared times y is 2y cubed. Then 2y squared times negative 3 is negative 6y squared. Okay? Then after that, same process as how you divide numbers. You have to subtract them. Okay? Your subtraction, 2y cubed minus 2y cubed, that is 0. We don't need to write the answer. So let's proceed. negative y squared minus negative 6y squared. Since our operation is subtraction, we will apply the rule keep, change, change. Okay? So keep, then subtraction will become addition, then negative 6y squared will become positive 6y squared, different sign, subtract. So negative y squared plus positive 6y squared, that is positive 5y squared. Okay? Then after that, same process as how we divide numbers. Let's bring down the next term, that is 0y. Okay, 0y. Now, let's focus on how are we going to eliminate this 5y squared. Okay, so to make it possible, you have to divide it again to the first term of the divisor. Okay, which is y. So, 5y squared divided by y. So, 5 divide 1. Okay, that is 5. Then y squared divided by y, that is y. Okay? We subtracted their exponents. Okay? Now, after finding the second term on the quotient, let's multiply it to the divisor. So, 5y times y is 5y squared. Then 5y times negative 3 is negative 15y. Okay? Then after that, subtract. Then 5y squared minus 5y squared, that is 0. Then 0y minus negative 15y. As you can see, keep, change, change. So we will be having positive 15y. So 0y plus positive 15y is positive 15y. Okay, then bring down 25. Now, let's focus on how are we going to eliminate this by dividing it to the first term of the divisor. So, 15y divided by y is 15. Okay, how? Because we subtracted the exponent of y, that is 1 minus 1 is 0. Therefore, 15y raised to 0 is 15. Okay? So after that, let's multiply this to the divisor. So 15 times y is 15y. Then 15 times negative 3 is negative 45. Then after that, proceed to subtraction. 15y minus 15y is 0. Then 25 minus negative 45. So keep, change, change. Keep, change to addition, change to positive. So 25 plus positive 45 is positive 70. In this case, we don't have any term here, and on our quotient, as you can see, we have here the constant. You have to take note that if you have constant on the quotient, therefore you have to stop dividing. Okay? So our answer should be this plus this divided by this. Okay? Again, our quotient or answer should be this plus this divided by this. Okay, here is our answer. Write the final answer. We have, okay, so we divided them. The answer is this. 2y squared plus 5y plus 15 plus 70 divided by y minus 3. Okay, you have to take note, we have here the quotient plus remainder divided by divisor. Okay? But if you don't have any remainder, therefore, the quotient should be the answer. Okay? Let's try another example. So, divide using long division. 15x squared plus 8x minus 12 divided by 3x plus 1. Okay, so as you can see, it is already written in standard form and there is no missing term because when we look at the exponent, we have 2, then the exponent of this term is 1, then after that, constant. Okay, therefore, that is
that is properly arranged. Okay? So let's proceed to the step number 2 wherein we have to write it the way we write when we are dividing numbers. So the dividend divided by the divisor. Okay? So let's have the computation. As you can see, as I said, you have to focus on how to eliminate this first term. So 15x squared. Then, how are we going to eliminate this? You have to divide it by the first term of the divisor. So 15x squared divided by 3x. First, we have to divide the numerical coefficient. 15 divide 3 is 5. Then x squared divide x. Subtract their exponents. That's why we have here 5x. Okay? Then after that, multiply the quotient or this quotient to the divisor. 5x times 3x is 15x squared. Then 5x times 1 is 5x. Then proceed to subtraction. So 15x squared minus 15x squared, that is 0. Then 8x minus 5x. Okay, keep, change. Okay, 8x plus negative 5x. Therefore, we have to subtract them based on the rule of addition. So 8x plus negative 5x is positive 3x. Then bring down negative 12. Okay? So we will be having 3x minus 12. Now, let's focus on how are we going to eliminate 3x. So 3x divide 3x is 1. Okay? 3x divide 3x is 1. That's why we have here 1. So 1 times 3x is 3x. 1 times 1 is 1. Okay? Then let's proceed to subtraction. 3x minus 3x is 0. Then negative 12 minus positive 1. Keep, change to addition, change to negative 1. So negative 12 plus negative 1 is negative 13. Therefore, as you can see on our quotient, we have the constant. So we have to stop dividing. So our answer should be this one, 5x plus 1 plus the remainder divided by the divisor. Okay? Again, 5x plus 1 plus the remainder divided by the divisor. Okay, this is our answer for this example. Another example, x squared plus 5x minus 28 divided by x minus 3. So we have to identify if they are properly arranged. So the exponent of this is 2. The exponent of this x is 1. Then after that, constant. Therefore, they are properly arranged. Then we will proceed to the solution. We have x squared plus 5x minus 28 divided by x minus 3. Now, let's eliminate this x squared by dividing it first by the first term of the divisor. So, x squared divide x is x. Okay? Because we subtracted their exponents. Okay? So, x times x is x squared. X times negative 3 is negative 3x. Then after that, proceed to subtraction. X squared minus x squared is 0. Then 5x minus negative 3x is keep, change. 5x plus positive 3x is positive 8x. Okay? Then bring down negative 28. Then after that, let's eliminate 8x. So 8x divided by x is 8. Okay? Because we subtracted the exponent of x. So 1 minus 1 is 0. When the exponent is 0, that is equal to 1. So 8 times 1 is 8. That's why we have here positive 8. So positive 8 times x is 8x. 8 times negative 3 is negative 24. Then proceed to subtraction. 8x minus 8x is 0. Then negative 28 that is keep, then proceed to addition, then positive 24. So negative 28 plus positive 24 is negative 4. So on our quotient, we have the constant. Therefore, we have to stop dividing. Therefore, our answer is x plus 8 plus negative 4 divided by x minus 3. That is our answer. X plus 8 plus negative 4 divided by x minus 3. So let us try this. Divide using long division. As you can see on number 1, you have to identify if they are properly arranged. Okay, so we all know that they are properly arranged, but there is missing term. Okay, because we have the exponent 3, we have here the exponent 2, but there is no exponent 1. Okay, therefore you have to put, or you have to include that term. Okay, the same as this number 2, we don't have 2 as exponent of x, or the variable. Okay, so you have to put that term with coefficient of 0. Okay, now I will reveal the correct answer. So the correct answer for number 1 is 8x squared minus 10x plus 20 minus 33 divided by x plus 2. Why minus? Because this is negative 33. Okay? It is alright if your answer is 8x squared minus 10x plus 20 plus negative 33 divided by x plus 2. Okay? That is also correct. Next, number 2. The correct answer is x squared minus 2x plus 1 plus 3 divided by x plus 2. That's all for today. Thank you so much and God bless everyone.